Okay, today's going to be Unit 8, Lesson 82, Populations and Climate. And this lesson is going to feel a whole lot like you're sitting in Earth space science today. I'm going to show you videos at the end of this lesson simply because I'm recording. But with that being said, I'm going to give you guys all the information first. Then once I conclude this recording, I'll show you some of these videos, all right? Okay, so again, this is going to sound a whole lot like it is an Earth space science lesson. So let's begin. I personally feel like it is critical that every well-educated man and woman knows the difference between climate and weather. You can't just step outside on a day in Florida where it has to be cold out and you need a sweater and say, man, Florida's cold. Okay, that's a snapshot of one day of 365 days. If we have a cold day here or there, that is not indicative of our climate. Climate are long-term atmospheric conditions. And trends. And these trends, these long-term trends and conditions, are supposed to span over decades, centuries, and even further. Aiden, what position do you play in the football team? Okay, so let's say Aiden has the highest completion rate of any quarterback in Hillsborough County. This means that he's the most accurate. There will be a dropped pass or a missed pass from time to time. It's going to happen. But if we look at the overall trend, he's the most accurate passer. Let's say that Cece has the highest GPA of any student at Plant High School. But let's say there's one assignment, maybe two, where she just bombed it. We're not going to say, oh, Cece, you're stupid. She had one bad assignment out of, say, 100. It's going to happen. It is not indicative of what she is or who she is. So when you think of climate, you got to look at the long-term trends. If you have 100 days of sun and 1 or 2 days of rain, you're not going to say you live in a rainy place. So don't get fixed on the here and now when you talk about climate. It is long-term. Weather is going to be current or day-to-day conditions in a specific area. And all too often, I kind of think that this is a symptom of the human condition. Just because a place feels like or displays weather where you are does not mean that that is representative of the entire planet. Right now, as I look at my Apple Watch, it is 66 degrees outside and it is 11:21 a.m. and it's sunny out. Does that mean that it is sunny with 66-degree temperatures and 11:21 a.m. everywhere in the world? Of course not. Of course not. I could ask my phone, what's the temperature in London, England? What's the temperature in Tokyo, Japan? What's the temperature in Sydney, Australia? Every place is going to be different. So be sure you understand the difference between climate and weather. Weather is like how you do in a class on a day. Climate is how you did in the class for the year. Long term. It really bothers me when someone says, oh, it's cold outside. See, we're not getting warmer. That's like stepping outside at nighttime and saying the sun exploded. It's not accurate. It is just a snapshot. Aiden has one incomplete pass. Oh, he can't throw it all. You can't just look at it at one thing at a time. It's a trend, long term. So what causes all these climate differences? When you think of Florida, we have a different climate than Alaska. Alaska has a different climate than Egypt. Egypt has a different climate than Vietnam, and on I could go. So what causes this? And the first thing is this image that you see here is Earth is on a tilt. And this results in uneven heating of the Earth's surface. So I'd like to expand on that. So what causes the differences of climate across the Earth? One reason is uneven heating of the Earth's surface. And why is there uneven heating? Because the Earth is on a 23.4 degree tilt. It is not upright. It is slanted. So I'll emphasize this line right here. This line I'm just highlighting on your notes, that is our axis, and we spin on our axis. Garrett, pop question. Don't let me down. Where is the North Pole? Where does Santa Claus live? Option A, here, the very top, or option B, the point where the axis intersects with the globe? A or B, first one or second one? A or B? Where's the North Pole? The second one is correct. So as you can see, it's not directly on top of the Earth because the Earth is on a tilt, which also means that the South Pole is here, not here. Okay? Now, I'm going to just, I want you guys to I know that, I hope you know that the sun is much bigger than the Earth. But just for explanation's sake, pretend that this is the sun, okay? I'm going to put an N for north and S for south. This means hemisphere. This line right here is the equator. Right now, as the Earth is positioned on this visual, Isabella, does it appear that the northern hemisphere is receiving more sunlight or the southern hemisphere is receiving more sunlight? The northern hemisphere. So what season would you expect the northern hemisphere to be in? Summer. And conversely, at the very same time, what season is the southern hemisphere in? Winter. This tilt causes the seasons. The seasons are more noticeable and more dramatic the further away you get from the equator. In Florida, we kind of joke that we don't have summer, winter, autumn, and spring. We have hurricane season, football season, snowbird season, and summer. But we don't get the leaves falling in the autumn. We don't get the frozen lakes in the winter. We don't get everything blooming again in the spring. We're consistent because we're closer to the equator. Florida is considered subtropical. But if you were in Virginia or New York State or Canada, you would definitely see a difference here. So that tilt causes the seasons. Now imagine this. I know you can't watch this if you're watching at home, but I'm holding a globe in my hand and I have the globe upright, no tilt. Okay? Now I'm going to talk really loud here so the microphone hears me. Let's say Cece is the sun. Right now, there's no tilt. 6 months later, the sun's over here on the other side of Cece. Is there any difference in how the sun is hitting the Earth? No. But now I'm going to tilt it 23.4 degrees. What hemisphere does it appear is receiving the most sunlight now? The northern hemisphere or the southern hemisphere? The northern. Now, how many months would it take for me to go on the other side of the sun here? 6 months. So I'm going to come over here. Now, what hemisphere is receiving more sunlight? The southern hemisphere. So once again, this tilt is the reason we have the seasons. And life has been evolving to adapt to these conditions. Put yourself in the perspective of a plant that is in the northern hemisphere in the summertime. Give me a yes or give me a no. You're a plant in the northern hemisphere in the summertime. Are you receiving enough sunlight? Yes. What season are you in? Summer. So is water in the liquid state or the solid state? Liquid. So and there's going to be CO2 in the atmosphere. So does the plant have what it needs to do photosynthesis? Liquid water, sunlight, CO2. Okay. Now let's flip it. You're now in the northern hemisphere in the winter time. Do you have more or less sunlight compared to when you were in the summer? Less. What's happening to water in northern latitudes in the winter time in the northern hemisphere? It's freezing. Can plants use ice to do photosynthesis? No. So there are 2 out of 3 resources that plants need for photosynthesis that are not available. So what do plants further north than us do when there's now limited sunlight and limited liquid water because you're in winter? What do the plants tend to do with their leaves? Shed them. Now, do we have to deal with that here in Florida? No, because do we have limited sunlight and limited liquid water in the wintertime? No. But up north they do. And the trees and the plants don't have enough energy to actually do photosynthesis. And so they shed their leaves. They're not dead, they're dormant. And then when all that ice melts and then the sun comes back in the springtime, days get longer, the leaves they regrow. Okay? I'm going to come back to a diagram like this shortly. Here's a quick question I'd like to ask you that I could never get straight when I was in middle school and elementary school, and I finally figured out a way to remember it. This is the equator. Is the equator a line of latitude or longitude? Which one isn't? You guys know? I can never get it right. So if you don't know, I empathize. Hey, now I'll help you out. You're on the football team. Your coaches make you do those exercises where rather than run up and down the field, you have to go side to side. Got me? Side to side. What kind of movements are you making?
Lateral.
Lateral. What do you call those muscles? They're on your sides right here I'm pointing to. Your latissimus dorsi. Dorsi means back. Latissimus means side. It's like your backside muscles. Lat means side. Does the equator go up and down or side to side? So is it latitude or longitude? Latitude means side to side. That's how I figured it out. There's two other lines of latitude I'm going to ask you guys to know later. That's the Tropic of Cancer. You'll write it down later. And that's the Tropic of Capricorn. They are going to be very important as we get into this lesson a little bit later, all right? Now, what I have here, I'm going to zoom out a little bit, is because of Earth's tilt, the sun rises and sets at different places in a given location. Up here is January. Down here is December. Actually, no, one more. Down here is December. I want you to look at where the sun is rising in each of these places. This photo was taken from the exact same location. You see that little castle right there. But look at where the sun is setting or rising, whichever. It's because the Earth is on a tilt and you have varying lengths of day and night. A lot of you know that I take care of the turtles here at Plant in that pond. I feed them twice a week. I clean their filter once a month. They're alive, partially because of me. But one thing I noticed as I observed them is, obviously, I hope you know that they are reptiles, and reptiles are cold-blooded. Reptiles love to lay out in the sun because they use the sun to regulate their own body temperature. Unfortunately for those turtles and where they are, between the months of November and March, the sun does not get into the turtle pond enclosure between Main Hall and South Hall because we are at an angle and the sun doesn't get there. But as we get to the end of March, a little bit of sun starts to get in there and the turtles are really happy. And then April, more sun, May, even more, June, July, August. They get enough sun to get energized and to have a little pep in their step. But they're a lot more sluggish at this time of the year because they haven't been able to lay on the sun. That's all due to the angle of the Earth. Okay. Oh, here's a cool story I just forgot. Because of the angle of the Earth, get this story. This is a true story. In Las Vegas, there was a building being constructed, and this building had all glass sides. And a lot of buildings in Vegas are hotels and casinos. They're one and the same. Well, this building was constructed and designed in winter. But then in the summertime, for just like a few weeks out of the year, the sun hit the building at just the right angle that it created a magnified death ray on an area of the pool deck below. And so here's the building. The sun hits the building like this. It reflects the light down here. In a zone of the pool deck, like plastic bags would melt, pool chairs would melt, people would get second-degree burns down there on the ground. And it was like an engineering disaster. So they had to fix that. And something similar to this, if you go to downtown Tampa, the USF Medical Building, you all know where that is? The intersection across from the wharf and near Amalie Arena. The building is shaped like this, okay? Well, when airplanes are coming to land at Tampa International Airport at a certain time of the year, the sun hits the USF building just right, and it creates a blinding reflected image where pilots can't see. And so if you next time you see the USF building, you'll see these panels over those windows to block the sun so it doesn't reflect and blind the airline pilots as they're coming into Tampa International Airport. That's only at a specific time of the year. So you got to understand that when you're engineering buildings, you got to take the whole year into consideration because the sun hits the earth at different angles at different times of the year. All right. Other factors that influence climate besides the Earth's angle is proximity to water. Land's proximity to water influences climate. So if you are close to water during the day, the coast is cooler than inland. When I was in high school, I grew up about 35 miles from here. So I grew up in the Tampa Bay area. And my biology teacher told us when you guys go to the beach, look in your car when you pull out of your driveway. Look at the temperature outside. And then as you get closer and closer to Clearwater or St. Pete Beach or wherever, the temperature is going to go down because the coastline is cooler than the inland areas. And the reason why is that the water, in our case, the Gulf, the water acts as a heat sink. Water has a high specific heat and it absorbs the heat from the sun. And I actually have a weather map from our local ABC channel that'll from a summer day. I want you to see how the inland areas like Haines City and Lakeland compare to St. Petersburg and Tampa and Clearwater. So check this out. Oop. Uh, look right here. Lake Wales, Lakeland, Bartow, Polk County, dead center of the state of Florida. Now compare that to Clearwater, St. Pete, Bradenton. The coastline is a bit cooler because the energy of the sun is being absorbed by the water. And so that cools down the air temp out there. Now, conversely, at night, the coast is warmer than inland because all that heat that the water was absorbing during the day is released. Can you get that, please, Camille? The water acts as a heat source. So if you remember back in January, we had a few days where it was unbelievably freezing for our perspective. If any of you have lived up north, you felt worse, but we are Floridians, and so 30s is like a nightmare for us. Y'all ever heard of I don't know if you've heard of this in downtown St. Petersburg on the first Friday of every month, they would open up the streets and just kind of like let the bars and the restaurants have a bigger clientele. They call it First Friday. They close down the streets to cars. They let people walk around the streets, go from bar to bar and restaurant to restaurant. Several years ago, they canceled First Friday for the first Friday of February because it was 55 degrees outside. Now, if you've lived in a different state, especially up north, you're like 55 degrees is shorts and shirt weather. But for Florida, that's like we're in a state of emergency. So that's just, I guess that's our Sunshine State preference. But what I want to show you now is this. This is a weather map for a winter night. Look at St. Petersburg compared to Bartow, same latitude. Look at Clearwater to Haines City, same latitude. Obviously, as you go further north, it's going to get colder. As you go further south, it's going to get warmer. So if you want to do this right, just compare two places on the same latitude. St. Pete, Bartow, Clearwater, Haines City, it's warmer. And when we have those really cold nights in January, the inland areas were in a freeze warning. That means that they put a cup of water outside, it would freeze. They were below 32 degrees. The coastline was not in a freeze warning because of this phenomenon. So your proximity to the water will definitely influence your climate. Okay? All right, moving on. This is going to sound a lot more like a Earth space science lesson here. A long time ago, not to get too political or religious or anything, this is just a history lesson. At a time, there was no science, right? And the Catholic Church really ran the show. Whatever they said goes. And at one point in our human history, the Catholic Church said that the Earth is the center of the universe. But I'm going to be more specific and say the solar system. The geocentric model states that the Earth is the center of the solar system. They did say universe, but I'm just going to say solar system. And I hope you can understand that geo means Earth and centric means middle or center. And this was the prevailing thought. You know, how humans are so special. We're in the middle of everything. And then there's a fellow named Galileo. I'm sure you've heard of him before. He had his telescope. He was looking outside his window and he was just looking at the night sky and he saw the biggest planet in our solar system. So trivia question, what is the largest planet in our solar system? Jupiter. I've sent you guys a few pictures over in mine. You can see Jupiter with the naked eye at night. It's easy to find. Galileo saw Jupiter and he saw these little things orbiting Jupiter. What were they? It's moons. Jupiter is a very large planet, so it has a very strong gravitational pull. It has like 68 moons or something. I don't know the exact number, way up there. And he realized smaller objects orbit around bigger objects. Is our moon bigger or smaller than us? Smaller. So do we orbit around it or does it orbit around us? It orbits around the Earth. And so Galileo realized, hey, the Earth is definitely smaller than the sun. The sun doesn't revolve around us. We revolve around it. And so he told everybody, we're not the middle of the universe, guys. We're not even the middle of our own solar system. And so the heliocentric, helium means helium because helium is one of the two main fuels of the sun, hydrogen and helium. This means that the sun is the center of the solar system. This contradicted the Catholic Church at the time. And do you know what Galileo's punishment was for speaking up against it? He wasn't killed. He was thrown under house arrest for the rest of his life for speaking the truth. Now, by the way, side note, this is why Darwin held on to his work for so long, because Darwin knew his history and he knew that there had been past scientists who had revealed new ways of thinking with new evidence. And it didn't go over very well. And that's why he kept it to himself. And even to this day, sometimes evolution can rub people the wrong way. Darwin knew that almost 200 years ago. All right. Now, moving on. Again, I want to be sure you guys know this, not just assume this, okay? When a planet revolves, that is considered when a planet travels around its star once. One trip around the sun. My little son just turned 6 months old last week, and I sent a picture to my parents, and I said the tagline, the caption was halfway around the sun. 6 months. It's halfway around. How many days does it take our planet to make one full trip around the sun? 365 days. Now, is our year and the length of our year the same as every other planet? No. So the definition of a year, or excuse me, the length of a year is subjective. It's different. Now, can you guys name a planet in our solar system that's closer to the sun than we are? We're the third. So what are the two that are closer? Mercury and Venus. So since they are closer to the sun, would you expect their year to be longer or shorter than ours? Shorter. It takes them less time to go on the sun. Name a few planets that are beyond us. Alex, tell me a few. Jupiter. What else? Give me one more. Neptune. Fine. Those are further away from the sun than we are. So are their years longer or shorter than ours? Longer. I hope that makes sense. I have a data table. You do not need a copy that just compares Earth to everything else. And you can see how long years and days are. Now, rotation is the time it takes a planet to spin once on its axis. How long does it take us to do one spin on our axis? 24 hours. Technically, it's 23 hours and 56 minutes, which is why we have to have February 29th every 4 years just to get caught up and put us back on schedule. A day is different on every planet. It does. And funny you should ask that. I want to show you this. Every planet does spin on its axis, but just to get the jokes out of the way now, the planet Uranus, ha ha ha. It has rings, first off, and I'm sure what other planet do you think of when you hear rings? Saturn. Now look at Saturn. Saturn is not like this. That's wrong. This is Saturn. So it's on its axis, right? There's its axis. Here's the planet Uranus. It's completely on its side. And astronomers hypothesize that during the early formation of the solar system, something must have rammed into Uranus, and it knocked it off its axis and completely tilted it on its side. So if you look at me, sorry if you're watching online, you can't see this. Here's us. Here's planet Uranus. It's completely in the wrong way. It's on its side. Something might have hit it and knocked it off course. All right. But yes, Ava, every planet does have an axis, and every planet spins on it. Now, this next one. This next one is a selective pressure, whether you realize it or not. Gravity. Gravity is determined by the mass and the spin or the rotation of a structure. Every planet, every star, every moon, meteors and comets as well have gravity. And generally, the more mass an object has, the more gravity it possesses. I'm bigger than all you guys. I have more gravity than you. An elephant has more gravity than me. The moon has more gravity than an elephant. The earth has more gravity than the moon. Jupiter has the second most gravity of our planets. And by the way, fun fact, because of Jupiter's intense gravity, it actually attracts a lot of asteroids that would have hit us. And I remember being 9 years old in 1994. There was an asteroid that had a pretty good chance of coming close to Earth, but because of Jupiter's intense gravity, the asteroid got pulled into Jupiter. And you could actually watch the asteroid hit Jupiter from Earth. There's a video of it where you just see Jupiter and you see a big flash because the asteroid hit it. So Jupiter takes a lot of bullets for us. But anyway, what I want to get at as far as natural selection is that as humans are continuing to explore further and further into space, we want to go to Mars one day. We want to go beyond Mars one day. A human life is less than 100 years typically. If we want to go deep into space, we got to figure out how to reproduce in space. And we have no idea how important gravity is for our development. So what scientists did is they sent some test animals to the International Space Station, rats, guinea pigs, bunnies, and they fertilized them. They got the females pregnant up in the space station, and they wanted to see how pregnancy would go. It went awful. Gravity has a major influence on the development of your skeleton, your muscles, your organs, everything. And when you don't have that influence, it got really, really messy. And so you got to realize that life has been on this planet for about 2 billion years. And part of the recipe for life is gravity. And if you just suddenly take gravity away from the equation of life developing, life can't adapt fast enough. And so it was really, really messy. And so we learned if we want to have humans reproduce in space, we've got to figure out how to simulate gravity. And so one way that we do it is we put them in a spaceship that spins. If you've seen some of these movies like Interstellar or The Martian, they're spinning a lot. That helps generate gravity. The reason why I throw this clicker up, comes back down, is to spin in the earth. Have you ever been on a fair ride that spins really fast? You get pushed to one side. That's kind of like how gravity works. It forces you down. Okay. So what I want to share with you guys here, and you don't have to write this down. I just want you to have that ooh ah factor. I want you to see how our gravity compares with other places in our solar system. So for example, compare everything to Earth. If you could stand on the sun, which you cannot do, you would weigh 28 times more. So if you were curling a 1 pound weight on Earth, that would be 28 pounds on the sun. If you weighed 100 pounds on Earth, you would weigh 2,800 pounds on the sun. It's intense. The sun's gravity is so strong, it keeps all the other planets in orbit. That's why the other planets just don't go floating away, because the sun's gravity keeps them in check. Earth's gravity keeps the moon in check. It doesn't let the moon just float away. Now, as a few of you said, Earth and Venus have shorter years than us. Now, those are Earth days. 1 year on Venus is 225 Earth days. 1 year on Mercury is 88 Earth days. The top line is the length of a year. I want you to take a look at the length of a year on the planet Uranus. Now, how many seasons do we have here on Earth? We have 4: summer, winter, spring, and autumn. And how many months in a year do we have on Earth? We have 12. So about how many months is each of the 4 seasons on Earth? About 3. About 3 months. We have 4 seasons, 12 months, 3 months per season. If you had summer, winter, spring, and autumn on the planet Uranus, how long would each of those seasons last, Ford? You have 4 seasons, 1 year is 84 years. How long would a season be? 21 Earth years. Yeah. Summer would be 21 Earth years long. That's crazy. The planet, or actually, they don't define it as a planet anymore, but ever since Pluto was discovered, it still has not made one full revolution around the sun. It's still out there and hasn't done one full loop, one full lap. All right, the middle row is days. I want you to look at Venus for a second. This is really weird. Ebba, what do you see about Venus's day versus its year? A day on Venus is longer than a year on Venus. It takes longer for Venus to just do one little spin on its axis than it does to go around the sun one time. And then check out the gravity. Venus is the most like us. It has 91% the gravity that we have. If we were ever going to Mars, Mars has a little more than a third of the gravity that we have. This is why, if you ever saw videos of the astronauts jumping around on the moon has gravity. It just has less gravity than us because it's smaller. Jupiter is 2.5 times the gravity that we do. So if you were benching 100 pounds on Earth, that would be 250 pounds on Jupiter. Saturn has 92% the gravity that we have, and so on. All right, so here's what I wanted to tell you guys. The length of a year is subjective. I watch a movie like Avengers Infinity War, and Thor mentions I'm 1,500 years old. A year based on where? Because a year on Earth is not the same anywhere else. Our years are 365 Earth days. A year on Mars is 687 Earth days, and so on. Every place is different. All right, let's get to the last part. This is probably the most important part of your lecture. And if we have time, I want to show you some visuals, okay? We have seasons, we have solstices, and we have equinoxes. I want you guys to first know about the solstices and equinoxes and how they apply to the hemispheres. And we have the northern hemisphere, we have the southern hemisphere. So I like to talk about the solstice. There's 2 kinds. There's a summer solstice and there's a winter solstice. Now, summer means the most daylight of any day. And the winter solstice is on the same day for the other half of the world. This is the least daylight of any day. And they happen simultaneously. If one part of the world is having its summer solstice, the other part of the world is having its winter solstice on that same day. And so to apply this to our planet, if we have the northern hemisphere experiencing summer solstice, what is the southern hemisphere experiencing at the exact same time on the exact same day? Camille? They're experiencing the winter. Now, you guys live in the summer solstice, so do any of you know what month of the calendar the summer solstice takes place, which is traditionally the first day of summer? What month would that be? Cooper, do you know? Do you know, Trey? It is June, around June 20th. So, Trey, when I say June, what season comes to mind? But if you lived in Australia or Antarctica, what season comes to mind when I say June? Winter. Yep. Now, conversely, if we have the northern and the southern hemisphere, and the north is in the winter, the southern hemisphere is experiencing the summer solstice. Ava Hamlin, what month of the year do we, northern hemisphere people, experience the winter solstice? December. So if you lived in Australia, or let me start over. When I say December, what season comes to mind? Winter. You know, we have Christmas lights and Santa Claus drinking Coca-Cola with polar bears, and we have Christmas and all that stuff, jackets and everything. You guys get Christmas break. If you lived in Australia, what season are you in December? You're in the summertime. They associate Christmas with heat and summer and beaches and surfing. So those two are opposites of each other. Now, I want to expand upon this with this visual for you guys. Here's the Earth. Here's the equator. This line is the Tropic of Cancer. This line is the Tropic of Capricorn. These are two lines of latitude that is very important for you to know. When we, and I say we, I mean us Northern Hemisphere people, when we have our longest day of the year, which is the summer solstice, the sun is directly over the Tropic of Cancer. But when the Southern Hemisphere experiences their longest day of the year, the sun is directly over the Tropic of Capricorn. So let's pretend that this is the sun. Claudia, does it appear that the sun is striking more directly on the Tropic of Cancer or the Tropic of Capricorn? I agree. So this would be summer up here and winter down here. So what I want you guys to gather from this is that when we have our longest day of the year on about June 20th, which is our summer solstice, the sun is directly over the Tropic of Cancer. That's as far north as it goes. On the other hand, you go 6 months later. Aiden, does it appear on the right-hand side that the southern hemisphere or the northern hemisphere is receiving more sunlight? The southern hemisphere. So this is going to be summer, and this is going to be winter. So when the southern hemisphere has their longest day of the year, which is like December 20th, the sun is directly over the Tropic of Cancer, which means it is furthest away from the tropic. I'm sorry, I said that wrong. The sun is directly over the Tropic of Capricorn, which means that it is as far away from the Tropic of Cancer as it's going to get. So this is how we establish the longest day and the shortest day. And the sun basically just is like a ping pong ball. And it bounces back and forth between the Tropic of Cancer, Tropic of Capricorn, Tropic of Cancer, Tropic of Capricorn, every year. So if it's going to the Tropic of Cancer once a year, and it's going to be over the Tropic of Capricorn once a year, how many times a year does the sun cross over the equator? It goes from Capricorn to Cancer, back to Capricorn, back to Cancer. How many times does the sun travel directly over the equator? Twice. It goes twice. And that's going to be an equinox, which we're actually getting in a few weeks. An equinox is when the sun is directly over the equator. And if you lived on the equator, you're going to have 12 hours of daylight, 12 hours of nighttime. This happens twice. We have the vernal equinox. Vernal means spring. And we have the autumnal equinox. Now, as I just said, we're about to get one of these in just a few weeks. You'll be on spring break. It'll be March 20th. Are we getting the spring equinox, which is the first day of spring, or are we getting the autumnal equinox, which is the first day of autumn? Okay. So in the north, what month does this happen in? March. And if you were in the south, what month would the vernal equinox, your first day of spring, be? What month is the opposite of March? First day of autumn. Or excuse me, yeah, first day of spring in the southern hemisphere. September. And then the autumnal equinox in the north is September. And in the south is March. Okay, so to sum this up, there's the amount of daylight in any given place on Earth will vary depending on where you are because of the tilt of the Earth's axis. Today, our length of daytime is 11 hours and 46 minutes. But when you guys are on spring break in just a few weeks, we will officially cross the 12-hour threshold, and we will officially have more daylight in a 24-hour day than we will have sunlight. The amount of day will increase every single day by about a minute and 40 seconds until we get to our summer solstice, which is the longest day of the year. After that, our days will get shorter and shorter and shorter until you get to the winter solstice, which is the shortest day of the year. And then after the winter solstice, our days get longer again for 6 months until you hit the summer solstice and then back. So for anywhere you are in the world, half the year your days get longer, and then half the year your days get shorter. We are in the phase where we're getting longer. And then once we get to late June, we're going to get shorter again. And then longer, shorter, longer, shorter. I want to show you a few things before we're out of here, but I'm going to